A warm welcome to today's webinar, Pencil to Pixel, Unearth the Potential of GIS in Civil Engineering. Today we will discuss about GIS tools and its application in civil engineering. Next, about ADS Technologies. ADS Technologies Limited was incorporated in 1994 to focus on providing PLM solutions, implementation and support. ADST is one of the largest technology solution provider in India and has served more than 1500 customers across India. We operate in 7 locations across India and are headquartered in Bengaluru. ADS Technologies is bronze partner to ESRI, and we also have strategic partnership with technology leaders like Dassault System for PLM requirements, US for additive manufacturing requirements, Human Solution for agronomic solutions for automotive and aerospace industries, Technia for issuing product data quality. ADST has also recently signed up with the phase 2 for Industry 4.0 solution for academia. For military solutions and training needs of aerospace and defense industry, ADST has partnered with Presagis and MAC for visual simulation solutions. With respect to EDA solutions, ADST works closely with Synopsys. ADST has sales, support, marketing, and customer satisfaction teams to address customers' business and support requirements. Extending its solutions, ADST has its own e-learning portal, ADST e-learning, which is the web-based training and skill development application with more than 135 CAD and domain-based courses with more than 12,000 subscribers. Today we have two speakers, Mr. Rohit Tiwari and Mr. Punit S, who are GIS specialists. I request all of you to ask your questions in question box, so we will answer those questions at the end of webinar. I now request Rohit to start his presentation.
Thank you, Yogesh. Good afternoon all. Today presentation agenda will be, we will start like introduction of GIS, what is remote sensing, how we acquire data, how we create data, and how we move those data to different platforms to do certain kind of analysis in our fields. And we will go to the digital twin. Digital twin is a new term coined by these like corporate sectors. This means virtually we can create entire ecosystem, man-made and natural phenomena on a virtual reality, and we can do the analysis over here, and by using those we can assess the future, and we can do the forecasting too. So we will see those slides too. We then go to the ESRI, different kind of ESRI products, entire ecosystem of ESRI products, those products which are like desktop products, cloud products, as well as mobile or web application products. Then we more go deep into our field like civil engineering, so how building information modeling and GIS can work together for the AEC industry, architectural engineering and construction industry. And we will see some of the example of GIS for engineering advantages of ESRI products and their application in engineering. We will see some of the packages which we are offering to the academia, highly subsidized packages, and at the end we will see some of the demo, live demo, application demo, case studies demo, which were created by our team. And at the end we will like conduct one Q&A session for you, so where you can ask your questions. So starting forward, we starting with the GIS. What is GIS? So GIS stands for Geographical Information System. This is a definition. Basically, in GIS is a system where we create, manage, and analyze all kind of map data and spatial data. Spatial data means any data which we have, like in form of Excel sheet or table. When we add the location information with it, it becomes spatial. And when we have a spatial data to deal with those data and do certain analysis over it, we need a special set of tools, a special set of platforms which ESRI provide. And virtually ESRI is the key player in this market, because practically 75% market captured by the ESRI, and more than 75% of Fortune 500 company using ESRI solutions. So you see many industries starting from government to private industry. I can tell you all big three telecommunication industry in India, like Airtel, Reliance, VI, Vodafone Idea. These three are using ESRI platforms 4G or 5G technology, locating the tower locations, or mapping their OCB cable networks. So how we can use GIS? So GIS, these are the terms which we coined. Like we can use GIS to identify problems. Suppose you have a data, you have a data of Excel sheet data of flood, where flood is happening in a certain area or a certain part of the city. So you can easily identify which are the root cause on the map. Like you can identify which part of the city is low-lying area because you have elevation data. You can visualize that elevation data in a 3D modeling, and by visualizing that data, you can identify pinpoint accuracy of that problem, and you can act over it. So once you had a pinpoint accuracy of problem, you can you can set your priorities over it. You can provide relief of those problems, or you can address those problems with the pinpoint accuracy. You can do the change monitor change. Monitor change means satellites are there in outer space. They are capturing data. Those data, some of those data are freely available. There are very fine data provided by European space agencies, even ISRO providing free data sets. So those data are there. Those depositories are there. You have to access those data. ESRI will provide you those platforms from where you can access those data sets. And if you want to do the change analysis, like in last 15 years or 10 years, how cities grow, which are the factors which are playing role to grow that city. So you can collect your satellite data from 10 years back. You can monitor like how the urban sprawl is growing, how the human habitats are going in certain area. All those spatial data you can collect, you can put in these platforms, ESRI platforms. Biggest advantage of these platforms are they are very capable to handle any kind of data. You can basically open your Excel sheet in these data sets. You can open hyperspectral and any kind of satellite data in those in these platforms. Once you have the periodic data, you can understand the trends, why this phenomena is happening. If you understand by it, if you collecting flood data for a city since 10 years, you can understand the trends, how floods areas are moving, how which low-lying area is now in more danger, which area now become highland area, and because of that the natural flow of water are disturbed, and because of that a certain area get waterlogged. So these kind of analysis we can do once we had those kind of data sets, and those kind of data sets will be provided by ESRI. Those kind of platforms will be provided by the ESRI, and those analysis tool will be provided by the ESRI. Only you have to come up with your hypothesis and your logics. Everything else apart from that will be provided by the ESRI platforms. Moving forward, so this is a poll time. We will going to publish one questions. Okay, you have 20 seconds to answer that. So my team, you can see on the screen, my team is currently publishing one questions on the screen. Polls open. You can answer. You have 20 seconds to answer that question. This question is we just learned about, so we will get better understanding what we are learning. Yeah, so suppose you answered your questions, and our team is analyzing, like the right answer will be the spatial data sets accurately. So moving forward, these are the results now. So the other terms which came into GIS is remote sensing. So what is remote sensing? Remote sensing is basically capturing informations about any object or phenomena while we are clicking image from our mobile phones. Our cell phones are a kind of remote sensing. Basically, we are capturing a phenomena or a object from a far distance. We're not getting in contact. So anything capturing informations without getting in contact is a remote sensing. And in our field, in GIS, remote sensing data, we refer to aerial data sets like satellite images, which we can you can see right hand side bottom. These are the satellite images. You can, drone images are a kind of remote sensing images, or any image which captured by the aircrafts, like 10 years back, 5 years back. Mostly the microwave data will captured by the flying aircraft. So sensors is it's a sensors platform, could be different platform, could be a satellite or aircraft or a drone. So this is how we can combine the remote sensing and GIS. So remote sensing data, like which are the images, raster data sets, which we call the images. Over it we create our data sets. Like we captured an image of a city. Now we want to capture all the road networks. So in the satellite data we can identify all the road networks. We can create those road networks. We can digitize those road networks, and then we have a data in an Excel sheet which contain all the information about the roads within the cities, like the name of the road, length of the road, thickness of the road, width of the road, when these roads are created, when this road get last maintenance, how many street lights these roads have. All those data sets you can attach the digitized map which you created. So if you see in the left hand image, so a bottom is a base map, which is satellite image, and the second last image is a digitized image. That is a layer. It's called layer stacking. So in GIS platform you can open data sets one over it over to other data sets, and anytime you can switch off, switch on the other data sets, and you can compare two data sets and visualize that. So how accurate data you created. So everything you can do that by creating digitized save files, by getting the remote sensing data. These remote sensing data came with the metadata. Metadata collect have all those information regarding that data, like when this data is captured, what is the coordinates location of this data, the location of this, everything, the sensor information, everything within the metadata. So for the higher analysis, we require those data sets, so we can borrow those information from those files. ArcGIS is a benchmark technology provided by the ESRI. So all those softwares come within this umbrella, ArcGIS, and ArcGIS is pretty capable to handle any kind of data, like imagery. We discuss imagery, tabular data, which is like Excel sheet and other data sets. Vector data is like our DWG files, our AutoCAD data. These are data are vector files, so you can directly open your AutoCAD file within in ArcGIS. 3D data sets. ArcGIS is pretty capable to handle a Revit model, so you can open your 3D data, or you can create your 3D data in ArcGIS. ArcGIS provide you 3D modeling. ArcGIS provide you the 3D terrain modeling. Okay, real-time data you can capture. Suppose you installed IoT sensors in the ground for capturing the moisture information of the ground, or the capturing the certain kind of pollution in the air. So those sensors are collecting information. Those sensors are collecting information and pushing that data to a server. You can connect that server with this system, and you can access that data in real time. So these platforms are pretty capable to handle real-time data. These platforms are pretty capable to handle big data. So you can do the big data analysis. LiDAR is another technology. We will see some of the demo of LiDAR data sets. It's a point cloud data. LiDAR is basically a laser technique. Laser is emitted from one device, and by the Doppler effect, you can say the ranging between the device and the object, a 3D image will be created of that objects, and you can open that 3D image in this software. So that 3D image could be a historical monument, or could be a city. This is not like people are not using, even government levels, governments are using this technology, LiDAR technology, to map their historical monument, to map their CBD area, highly dense area, to keep information about every inch, because these data are very accurate, like accuracy in a millimeter. So now governments want to have information about every inch within the CBD or any historical importance place. So they are collecting these data sets, and they are using ESRI platform only to collect those data and do the analysis or building the real-time model over it. For the engineering, so any kind of data sets you can connect with the ArcGIS. Like if it's AutoCAD, so I already said DWG files, you can directly open your CAD file here. You can directly open your CAD file. You can georeference your CAD file. Means georeference means if you open that CAD file on a satellite image, it will exactly open where you created that model. Like I want to create a building in a certain plot area, and that plot base area I have, over that I created a AutoCAD files, AutoCAD design, but now I want to visualize the real scenario. Like what are the real scenario of that place, of that plot. So if I georeference that AutoCAD files, that once I georeference, that AutoCAD file automatically open in GIS platform in that place. So you can easily visualize where that place is, what is the scenario surrounding that place, is my design is suitable. So this is how this design and geospatial data works hand by hand. This is again a poll time. Our team going to show one more questions for you, for the audience. They can answer it. You will have 20 seconds to answer this question. Okay, and once 20 seconds over, we will show the answer of that question. So read carefully the question and try to answer that. It's just reflect how we are understanding, and it's also help us to like improve our delivery quality, so we will deliver better to get the audience understand the technology better.
Rohit, I think 80% have answered it is data about data.
Yeah, so it's metadata is data about it. Okay. So this is an example how if you open your drawings over a satellite image, so basically the right side is the satellite image, we will see that demo at the end. So this is how you can visualize like what the construction, what the area where you planning the construction, how that area is, how densely that area populated, how much green cover that have. So according to that you have a location intelligence about that area, and based on that you can change in your designs. This is how a design and geospatial world work together. Moving forward, digital twin, we like discuss little bit about these terms in starting. So digital means basically creating a digital virtual model of real scenario over at virtual platforms. So when you create that virtual representation of real world, including physical object, processes, relationship, behavior, man-made behavior, natural behavior, everything you can create using GIS. And these digital twins should provide you the insight and the information. Like once you created those construction in that area, how which factor going to affect which part of your constructions, how your constructions going to work, how much load that construction is going to bear in near future. So everything can be analyzed and can be visualized in real time in a virtual. So based on that you can do the changes in your designs. So this is how this digital twin model work, and this is a very very reliable and very help you to create a efficient designing. Real-time visualization, like we discussed a little bit about, like you can integrate your IoT sensors with the GIS platform, so you can access the real-time information with it. You can create the dashboard. Dashboard basically is a GIS WebGIS platform where all the data which collecting from the ground can be represented in a form of chart or by pie chart. So it's better to visualize. You can generate report over it. You can do the insight and analytics over it. Like advanced visualization, you can also do. You can, like, this is the example of advanced visualizations. You can create your 3D model over it. You can do the network analysis. You can do find out the suitable network. Like now organizations like milk productions and grain production, they are using real-time data to track their deliveries, to track their automobiles, and based on that they are doing advanced analytics, like deploying an advanced analytics, how they can based on this information, how they can improve their networks, supply networks, so they can plug the revenue losses. They can definitely these tools are helping them to improve their profits. So now we will discuss about the products. So basically ESRI products we divide into three parts: desktop, devices, and servers. So desktop app, there are several products, okay, like there are hundreds of products are there which are targeted to different applications, but we will going to discuss some of the major products like ArcMap, ArcGIS Pro. So these are City Engine, these are desktop applications, and with more than 1,000 number of tools, like n number of tools are there, n number of algorithms are there. Based on our requirement, we use those tools in different way. You can do mathematical modeling here, you can do visual modeling here, you can literally create a digital twin using these desktop applications. So ArcMap, ArcGIS Pro, these are standard flagship products of ESRI. Most of us, we are using currently a desktop applications. If you go to the devices, like if I'm students and I want to collect data from the ground for my survey practices or my survey subjects, so I can use applications like Survey 123. So in which I can create a survey map. I can go to the ground, collect data from the ground. That data which can directly reflect to the my online account, cloud account. No need to go to the lab and uploaded those data to some server and create maps or pie chart or dashboard. Those dashboards can be created automatically, and little bit configuration only required. So anyone with little bit information of coding can also work on these tools. Site scan is a drone data processing, drone data survey application. So basically in site scan we will see in detail also site scan, so when that we discuss. Similarly the ArcGIS Online and Enterprise. So ArcGIS Online is a SaaS product, software as a service. If you purchase ArcGIS Online, don't need to install that solution within your system. It's installed in somewhere in a cloud. Definitely that cloud is qualifying the MINFI conditions, so that those clouds is within the India, and your data will be protected, 100% protected. And no need to install any systems. Like if you travel to somewhere else, you just require your credentials and internet connection. Any system you can access those data, you can do analysis over it, you can share those data within your team or with the public. It's very simple. ArcGIS Enterprise is an enterprise concept. Enterprise means you can integrate n number of data, n number of type of data, like real-time data, CCTV feed, camera feed, real-time traffic data, motion detector data, data from the land parcel, land record department or forest department. These all data can be integrated on one platform, and using that platform you can create your own GIS application. Own GIS application means I don't require 1,000 tools. I only require 20 tools to do my analysis. These 20 tools are enough for me, and I don't want to purchase 50 number of licenses. I just purchase one enterprise. I created one WebGIS application, and anyone within my within my organization, I share the credential with them. I can monitor their activity too if I am an admin of the enterprise, and with the credentials they can access that web application on any system. There is no restrictions, and this application work as a GIS application. So enterprise is a very huge setup, and it provide you like n number of possibility to create n number of analysis. You can share your data, you can create WebGIS portals, you can like handle all the data sets which are coming to your departments, and big organizations currently using this. More the smart cities are currently using ArcGIS Enterprise. So this is the brief representations of how ArcGIS Enterprise will look like. So the portal is connected from the desktop, web, and devices. So all those data coming from the different devices, web portals or desktops, they come to directly to the portals, and the portals, pre-configured portals, those data can be converted into graphs, pie charts, or just point on a map. So what you want, it's up to you. You can convert in data in that format, and anyone with the credentials can access that data. That portal is capable to handle, they have GIS servers, so any spatial data you can handle, image server, so any images like satellite image, drone image, lidar image, any kind of raster image, you can handle that. Geoanalytics server is there, so any analytics tools which ESRI built till now, like I can give you 1,000 number of analytics tools are there. All tools are there, so you can use any tools to generate report. Geo event server basically handle the real-time data. So all this capability you can combine and create one portal, and that portal is work as a GIS solution with GIS solution. Now this is very important. I want to discuss it with, like, in GIS, like when we are studying in our college, we face the data crunch because GIS or any software you want to do the analysis, first you require data, input data. Like I have a hypothesis. For that hypothesis, there are 4 parameters which are affecting those hypotheses. For 4 parameters, I required 6 number of data, but I cannot have 6 number of data, and there are literally no source to collect those data. Like I want a village level of boundary map of India. If you go to any department, it's very hard to get those data. But ESRI has those data sets. ESRI has 2 data repository with it. One is called Living Atlas. Living Atlas is basically entire world, including India, and Indo-ArcGIS is specifically for India. So in Living Atlas, all those data sets which were created or which are floated by some research organization, these data are highly verified, so you can trust this data. You can they can see which organizations is publishing their data, is ISRO, NASA, or NOAA, which agency is publishing this data. And for the Indo-ArcGIS, like ESRI is a part of major government projects, and now government this current government is more liberal about the opening the data, so they open most of the data for the public, like village boundaries. These data are very hard to get till 3 years 4 years back. Forest boundary of India, road networks of India, railway networks in India. So any data of India you can get from Indo-ArcGIS, and there are inbuilt applications also. You can use these inbuilt applications built in point to provide the solution to the government or the private organizations. Again, there will one question will be published by our team. Okay, and similarly, these questions are based on what we get understand till now, and this you all get 20 seconds for these questions, and after 20 seconds the correct answer will be published. Okay, so
Rohit, I think 43% have voted for vertical, 37% have voted for tangential, 11% none of the above, and 9% is horizontal, which is the correct
okay
answer.
So z-axis is basically vertical data sets. So like if we are creating any data with, and we providing the z-axis with z value, that means we are providing the height of that object. Okay, so z is that vertical data is the correct answer, and I think most of us answered the correct one. So now moving forward, GIS and BIM. So GIS and BIM, ESRI and Autodesk recently got partners to provide a central stage or central interpretation for the construction project for more sustainable and resilient future designs. Basically, using Autodesk, you can create your BIM model, but using ESRI, and both these you can collaborate this data in any platforms. You can open your Revit model, AutoCAD Revit model in ArcGIS. So you have design data, other hand you have a geospatial data. So you can club these 2 data sets, and you can understand like where you are constructing the for which conditions you are constructing the designing these projects, and what are the real issues those areas are facing. So based on that, you can design more sustainable construction projects. Side scan, okay, so side scan, which we discussed a little bit about, it's a also a SaaS product, software as a service, so no need to install any system. You just require your credentials and your internet connection. So what it do everything which will required for the drone survey, okay, for the flying, for autopiloting, everything. Once you link your drone with this software, there is hardly any human interaction required for the data processing or the final result getting. Like I go to ground, I map the area, this area I want to do this survey. So okay, so like software will ask for me like what are the pixel area you want, what are the like overlapping you want for the clear 3D modeling. So I provided this answer to the question which software asked. I provided that. The software will take as an input. They created a flying model for the drone. I go there, I just fly my drone and forget. Drone will fly, automatically follow the path, capture the data. While capturing the data, the drone will upload that data to the cloud if internet connection is there. If not, then you have to upload that data to the cloud using your system. Once data is uploaded, you have to choose what kind of output you want. You want only ortho image, you want point cloud data, you want 3D model, what kind of data you want. You want the elevation model. I choose like these 4 product I want. Based on that 4 product, I can based on that 4 product, the image will be the analysis will be done, the processing will be done, and I receive one in like input in my mail once processing are done, and I need to go there and download the data. This is how simple you can do the drone survey and collecting data and building your models. Other part is data collection, so we will see some example of it. For the survey, most of the survey we discuss this tool, survey 123. So this is a mobile application. You can create your application form for the data collection from the ground. You go to the ground, collect the data. That data automatically go to your cloud based profile or your profile, and that data you can, anyone who have credentials can access in real time. From now, I request Puneet to take for the presentation.
Thank you, Rohit, for the brief explanation about the products and about the GIS and remote sensing. So I'll be taking in this session. I'll be speaking about the domain-specific application of GIS. So we'll start with the digital cartography. We all know that know that the map is a model of like reduced scale model. So we represent features on the Earth in the map, like in a reduced scale. So cartography is an art of map making. So so digital cartography is a thing like in the conventional method of map making, we used to collect the data, go to the field and draw, like using pencil and scale, like we used to draw maps and publish the maps. After the digital era, we got the like CAD, we use the 2D drawings, we use digital format for making a maps, drawing features. Now in the CAD maps or 2D maps, we missed a major part, like it's a projection. So we know Earth is not a perfect spherical. It's in a geoid shape. So the projection plays an important role in precision of the maps. So GIS platform offer you the projections. So here we can map our area or any region with precision. So digital cartography offers us like map making in the with projections, and we have a large number of digital library, digital symbol library. So we can symbolize any features on the we can publish that maps. So we'll go moving forward. So here it's a classic example of a map. survey of India topo sheet. If we check left side of the map, we have a legend where we the symbol and representation is showed, and its a description is showed. So similarly, in the GIS platform, we have a symbol palettes, so we can bring any symbols to the map, and to the scale, like 1:1 scale, we can prepare a map. So next slide, please. So we will be in detail, we'll be discussing about the GIS application in our civil domains. So when it comes to urban planning and design, the sustainable habitat planning demands a comprehensive understanding of existing land use and topology of the terrain. So for planning utilities in better way, the availability of total information in the spatial and non-spatial data could be integrated in the GIS domain, visualized, analyzed, and brought into the 3D modeling as well. For example, urban planners and engineers are required to plan optimum routes for transportation, construction of utilities in better utilities like pipelines for water, gas, sewerage network, etc., with minimum cost and time effective in different terrains. So GIS offers platform offers these tools, so you can model your terrain, and see before execution you can plan everything virtually. You can visualize the utilities and plan what about the plan. The planning is also a predictive in the sense that it must identify alternative future and evaluate these in terms of goals which are based on the values. Also planning is it's a political in nature, so you have to include not only a spatial, a non-spatial, like demography and the interest of the local area. So you can integrate all these informations. So and you can plan a better, a sustainable urban for the future. So similarly, mapping of utilities is a part of urban mapping. So here we collect the data from like buildings, electric network, natural gases, or any water supply network, sewer, existing networks. So here we can inspect and manage using GIS softwares and tools. So for example, for the data collection, we can use a mobile GIS. Here we can go to the field and giving the geocode for the asset, and we can creating an attribute for that particular feature, and we can real time in the office, people can get the data, they can analyze, they can inspect that in the real time, they can inspect the feature, and they can manage better manage that. So application of GIS in utilities are like asset. Okay. For the transportation, application of GIS in the transportation. So we know like transportation, GIS significantly aids in planning, monitoring, and managing complex system involved in transportation system. So planning and so GIS in the transportation is a widespread. So major areas of application includes highway maintenance, traffic modeling, accident analysis, and route mapping, route planning as well. So all three modes of transportation, GIS could play a major role. Like for the ports, like GIS in the public transportation. So GIS could utilized in the perform monitoring of any system, like public transport system, route planning, optimization of route planning, safety and security of a transport system, asset management. If any there is a asset with regard to public transport, we can manage those things. Operations of transportation, and customer, and also we can also get the customer information, like a demography information, how the transportation system is delivering or serving a demography. A case study will be discussed later. So when it comes to the water resource GIS in water resource management, here in water resource management, we can do a water resource assessment. Like we can in the GIS platform, we can model the whole system, watershed system, like hydrological modeling we can do. Here water resource management, like integrated water resource management, like surface water thing and subsurface water thing. We can model that. Water accounting could be done, and we can also do the water resource development, like for any build a dam, like site selection for site suitability selection for a dam, check dam for natural resource management, or like water harvesting structures we can analyze using GIS tool. So watershed development we can do. Watershed development in the sense a ridge to valley, so where we can conserve water, we can build a water conservation structures, also soil conservation structures. Ridge to valley we can use a plan using a GIS model. So flood disaster support we can do. Most importantly, the environmental impact assessment and its management is the major application of GIS in natural resource management. So moving forward, so environmental engineering. So for any project, before starting its activity, we need environmental impact assessment for any project. So GIS could help us to collect that information regarding the environment. So before starting the project, we could do the analysis, like what extent the project could affect area. For example, the dam construction. For dam construction, some villages will be in the backwaters. Villages could be inundated. So we could check. We could build a model before construction of dam. We could see the height of this MSL. What would be the area or villages could be inundated. So these kind of analysis could be done using GIS. So site selection, restoration, and remediation. Like for example, once we select the mining area, once we do all the exploration is done, so we have to restore the area. Like we have to restore that. So to what extent the restoration has done. So those analysis could be done using remote sensing and GIS tools. So, moving forward. So in the GIS application in earth science, So here, for example, we could collected data. For example, soil profiling we do. We do. So here we can model that data. Subsurface of the earth could be modeled in the GIS platform. We can analyze that. So we can manage those data. For example, we collect samples of any area. So we could interpolate those data, and we can interpolate those information into a vast area and model that and use it for many analysis. And and also we can integrate many layers, like not only the spatial, the non-spatial as well. We'll integrate those and use for various analysis with respect to geology. Moving forward, and geotechnical engine. So using remote sensing data set, like a DEM, DSM, digital elevation model, we could delineate a watershed. We could check the slope of the area. We can calculate the slope of the area, aspect of the area. And we could integrate all other information for like landforms. Those information could be integrated and analyzed for various projects. So for example, like we take a borehole data. Borehole is a sample data which we could collect for the analysis of the mineral exploration. So we could interpolate that in the GIS softwares and get the insight of the inside of the area and quantify the minerals available in that area. So these are the classic examples of GIS applications in the civil engineering thing. So moving forward, Rohit will be explaining about the will be demonstrating the live examples as well as the GIS packages. Thank you.
Thank you, Puneet. So yeah, we will see some examples demo. Before that, we're going to discuss about the packages which we are offering to the academia. So in these packages, the licenses are not limited, divided into certain groups, as well as for the licenses are not limited to one software. There are these 4 categories of the softwares where we provide like ArcGIS Pro desktop applications with all the extensions including the advanced level of extensions. We will provide the City Engine software specifically designed for the architecture and urban planning. For the civil engineering and urban planning students, the students who see themselves as an urban planner or as a landscape architecture in coming future, they're definitely going to use this software. This software is very useful for them, and most of the leading organization consultancies, they are using City Engines. And the enterprise advanced, like we discussed about the ArcGIS Enterprise, we are providing ArcGIS Enterprise to the academia also, so that students can learn to build new applications, GIS applications, mobile applications, web applications, how to create your data into application. So when you share, no need to share your data on a PDF map. Like I collected data from the ground, I projected over a satellite image or base map, Google map base map, and populated one PDF map and take a printout and share with it. No need to do that now. Now the world is moving toward the WebGIS. You can create your data into a map format, into WebGIS format, and you can share that link with anyone. So whatever analysis you want to do, if you want to zoom in the data, you want to export that data, you want to tilt that data if that data is 3D, so he can do a number of things over it. And that's why we are providing the ArcGIS Enterprise to the academia, because ArcGIS Enterprise is basically for the organizations, big government and private organization, and they are using. But we are providing academia because the students who now get familiar with this technology, because this same set of applications go to the corporate sector. So once they go placed and they go to some company organization to do analysis or work as a GIS specialist, there is no gap between the academia and or industry. Whatever set of skills or softwares we are providing to the industry, same set of things we are providing to the academia. Similarly, we will provide the online tools. There are 10 online tools are there: ArcGIS Earth, ArcGIS Online. All these SaaS tools will be provided. Using these tools, you can share your data any around the world, and you can connect with any researcher. You can use their data, any research or organization data you can use to do your analysis, to create your own analysis, to create your own map. You can get connected. Those data repository has a number of free courses. So courses are specifically for different streams, different domains. Like I'm a civil engineer, but I want to learn about the data science, I want to learn about the algorithms, how to create mathematical algorithms using AI/ML. So all these courses are there, where free courses are also there, paid courses are also there. So but there are like many free courses are available, highly free courses are available. You can learn those courses, you can get certified from there also. Now we go to some case studies quickly. So basically, this is a project where they collected data, drone data, for a construction project throughout the construction times. Okay, so what is the benefit of it? Like I want to monitor my construction project which are going on in Hyderabad, but I'm sitting in Delhi, and every 15 days I want to see my project on time or not. So this kind of technology help. If you have a software called like a site scan, anyone who is flying that drone, every 15 days you are getting that data. based on that data, you can see how much development happened since last the data is captured. So this is basically a data repository, your personal data repository. You can click on any date. At that date, if that survey is happened, so what is the level of work? This was the level of work. This is how much work was done on 15th July 2019. So is that work on schedule or not? And these data are collected using aerial sensors. So these data are highly accurate. You can do the measuring also. Like if I want to do the column measures here, like this column length is okay or not, so I can do that measuring too. Okay, so you can basically do the measuring too. It will provide what is the distance here, and definitely it's the 3D data, so it will also provide what is the vertical deflection you had while you having the that data measure. So this is how you can use these tools. And I want to remind you, I'm using these applications, but this application is online. Okay, this is a WebGIS concept. Similarly, like I told you, you are collecting data, but you want to represent your data as a application, web application. No need to share that data in any format, PDF format or Excel sheet format. You can directly share your data as a web application. So I just required my credentials. I have ESRI credentials. This data is shared with me with some organizations. Okay, so I can use this data. Similarly, any students can create their own web applications. We will see some other example. This is also a WebGIS concept. So they did the survey. This is aerial based LiDAR survey which we discussed. So LiDAR is basically a laser based ranging device. They emit laser rays, and by the time that those laser beams are coming back to from the area, based on that they can calculate what is that, what that object is, how that object look like, what is the height of that object. So based on that they create that model, and these are very accurate models. You can do analysis over it, you can create your models over it. So because these points are very accurate coming from the object, by joining these points at each height, you can basically create the entire stadium model, and this model will be very accurate. So this model will be saved and it can be used as a future reference. You can see the classification based on the heights, the point collected from based on the heights, like which heights which points are coming. And you can like filter out, I want only building 5 points only. So all those points like trees, roads, all those points will be gone. Only buildings top points you are getting. So this is how you can do analysis. You can on collected data. And once again, this is a WebGIS concept. This data is hosted on a cloud, and someone created this web application and showing this data as a web GIS application. Okay. Now going forward, this is this data collection methodology. So here someone created one form, survey form. Based on that survey form, like these are the questions are there. You put those questions, you mark those locations where you want to collect that data, you put that questions and submit that question. Okay, submit that form. Once forms are submitted, that data will reflect in this dashboard. It's a real time. So this dashboard is loading. Okay, so this is the dashboard. Now just remember these points. Now I want to collect one data. Okay, I'm collecting randomly, so I collect, and any point I want to mark. Okay, I marked there. Now I want to submit. I'm submitting this data. This data will be submitted. Okay. Now open the dashboard. just refresh dashboard. Yeah, this is the point which we captured now. So you can see in real time this data, you can fetch this data from the ground. So previously it's a 15 number of points which are collected. We collected these points. This is the point we are collected. This is the data we collected. We mark a white path with sidewalk and unsafe, pedestrian, unfriendly, and neutral. These are the data we collected from the form, and we mark that, and you can see in real time this data is reflecting on the dashboard. Similarly, you can use this mobile application on the ground. You can upload this form on the ground. You go on the ground, collect data in the real time. Anyone sitting on the lab or your data center can visualize that data in real time. Similarly, like Puneet was discussing about how urban transportation system can be worked with GIS. So this is the Melbourne City urban transportation networks. These networks include bus stop, tram stop, train lines, trams, bus route, bus route for metro, bus route for region. All those maps are here. And using GIS map, they basically run a study. Okay, like the studies like who lives within the within the 15 minutes walk area of any stop. Like this is a stop, they choose F, and they calculate like if your walking speed is 5 km/h. So within the 15 minutes, if someone start walking from this stoppage, which area he will reach. So they did that study. They also did studies like this is also a study like within the CBD area, the central building district, CBD area. If someone wants to reach that CBD area within the 15 minutes or 40 minutes, within a certain time limit, which part of the city is you can reach easily. So these all green zone, if you want to reach central district, you can reach within 30 minutes using urban transportation system. So these kind of hypotheses they develop, these kind of questions they develop, they have these data sets, so they are able to do this kind of analysis, they are able to do this kind of study. Similarly, if someone from civil engineering, they develop their own questions regarding the urban transportation system in their projects, and they have their hypothesis with them. They identified the factors, the parameters which are affecting those and they're causing that problem. So they can use those parameters, everything, and data will be provided by the ESRI platform, provide you those data. Or some data, if need to be collected, you can collect using the ESRI platforms. You can collect those data from the ground, and everything can be integrated in one platform. And you can develop a WebGIS application or dashboard to share with your faculty members or your team members or anyone like external guides or someone to get their insight or present your data. This is one of other example which I want to share. This is a network analysis. This basically shows us the 3D elevation map. So this is a map created for the tourist which go to the hiking in Switzerland. So like if they choose any hiking route, so what is the difficulty level, where that route is started, how you can reach that route, where you can stay in that route, every information is there. So this is kind of analysis, or this is a kind of study, any kind of study we can do using these applications. These are the case studies, more case studies. If you want to see in details, we can also give you more case studies and represent better as per your requirement. This is a leading institute in India which are currently using ESRI GIS solutions with them, including like top IITs like Delhi, Mumbai, and the private universities like CEPT and Amity. These universities are currently using ESRI GIS solutions, and their students learning these GIS skills and getting placed in the market, because there's a huge opportunity in GIS market, not only in government organization, also the private organizations too. They set up their entire GIS teams, and more if the students had familiar they are familiar with the ESRI environment, ESRI tools, how these tools are working, and most of these organizations only using these tools because these tools are very reliable. So it's like there are high chances to getting job in these industries.
Thank you, Rohit. Thank you, Yogesh. I would request the audience to give their feedback once you close the session. Thank you everyone for joining us for today. Thank you.